Hi, today I want to go over the section 2.1 and 2.2 of elementary statistics. Section 2.1 and 2.2 both are talking about the different graphs that we can use to organize the data. We already learned in chapter 1 how to collect the data. Now we want to know how we can organize data and put them in table and graphs to have a better visualization about the shape of the distributions or the data. The first graph that we want to talk about is called the stem and leaf plot or stem plot. Stem and leaf plot will be used for quantitative data. That means when the data that we collect are just numbers, because we want the numbers to put some part of the numbers into a stem and some part into leaves. We usually put the leftmost digit of the number for the stem and the rightmost digit for the leaf. Okay? Stem and leaf plot is good when we have small data sets, but it also is not effective if you have various small data sets, okay? And not if you have a large data set, because it's hard to put a lot of data into a stem and leaf plot. And it's one of the simplest and fastest way to represent the shape of the distribution. And we can also use the stem and leaf plot to compare the distributions when we have a back-to-back stem plot. I will show you in the next slide how you can create a stem and leaf plot. And remember, that's important, that create a key for any stem and leaf plot to let the reader know how did you create that stem and leaf plot. For example, we want to display this data in a stem and leaf plot. As I said, stem and leaf plot has two columns, one for stem, one for leaf. So the rightmost digit of a number, it goes for the leaf. The last digit of any number is for the leaf. So if your numbers are all two-digit numbers and the last digit is supposed to be for leaf, only one digit left for a stem. Okay, so remember, we put all the numbers in a stem and leaf in order from least to greatest. From stems must be in order from least to greatest, and for leaf also must be in order from left to right in order. Okay, we're not going to repeat any number for stem, but we'll repeat if we have any repeating number for leaf. Okay, and it's easier to keep all the numbers in order to put them in a stem and leaf plot, because that makes it much easier for you to just put them in this plot. As you see in this data set, I have 1, 2, 3, 4, 5, 6 numbers starting with 20. Okay, so the first digit must be for stems, and I have 3 different digits for a stem, since I'm not going to repeat numbers in a stem. So 2, 3, and 4. But for leaf, remember, if there is any repeating, you must repeat it. Okay, so the last digit of all of those numbers starting with 20 must go for leaf, and it must be in order. So 1, which is 21, 5 for 25, 5 for another 25, 6 for 26, 7 for 27, and 8 for 28. For numbers that start with 30, I have a 0, which is 30, 6, and 6. For 40, I only have one number, which is 5. And I'm done with the stem and leaf plot right now. So the only thing that's important, you need to keep the numbers in order, in a stem and in leaf. No repeating in a stem, but all the numbers must be in leaf. And if you look at this stem and leaf plot, if you flip this 90 degree, you will see they're creating bars that gives you the shape of the distribution. Let's look at next example. This time we have 3-digit number. So that means if I keep the last digit for a leaf, I will have 2 digits for stem. Okay, so this time the stems must be 2-digit number. So the different stem that we have are 12, 11, 10, 13, I'm not going to choose the repeating one, 40, 14, and 9. I put these numbers in a stem in order from least to greatest. 9, 10, 11, 12, 13, and 14. Now start writing the leaf. Leaves are the numbers that start with 9. Is only 95. The numbers with 10, I have 100 and 101, which is 0 and 1. For 11, I will have 114, 119, 116, and 116. We have to keep them in order, remember? So we have 4, 6, 6, and 9. For 12, I have 129, 124, 128. So if I put them in order, I have 4, 8, and 9. And for 13, I have 134, 136, 134, which is 4, 4, 6. For 14, I only have one number, which is 146. And it's important that you don't need to put the commas between the numbers, just leave some space to separate the numbers. And something that's also important to make it nicer is just put the numbers, the first numbers, on top of each other, the second numbers, third numbers, okay? And don't forget to write the key. Write the key. For example, just choose one of the numbers. That's up to you which number you want to choose. I will choose 116 out of this data set. And I say 116 in this stem and leaf plot shows as 11 for stem and 6 for leaf. And that is called the key for this stem and leaf plot. Stem and leaf plot is also one of the graphs that helps us to find the outlier. Outliers are numbers in data set that does not fit with the rest of the data. And we also call them the extreme values. Okay, some numbers are too far, too small, or too big comparing with the rest of the data. They called outlier. For example, I want to use a stem and leaf plot and find if there is any outlier in this data set. These numbers are decimals. I can use stem and leaf plot for decimals as well. And how I can put the numbers in a stem and leaf plot, if I want to show the key, I say 1.1 in this data set shows as 1 and 1. That means the first number goes for the stem, the second number goes for leaf, the decimal part. So again, I will have a stem and leaf. So the numbers right now are in order. So I have 1, 2, 3, 4, 5, 6, and 12. These are the stems. But make sure to put them in order. 1, 2, 3, 4, 5, 6. I know there are 7, 8, 9, 10, 11, and 12. I know there are no numbers for 7 to 11. That's why we can see, if we leave them blank, we can see the outlier. We can see a number that is far away from the rest of the data. And if I put the numbers for the leaf, I will have 1 and 5, 3 and 5 for 2, 2, 3, 3, 5, and 8, 0, 5, 5, 7, and 8, 5 and 6, 5 and 7, no numbers there, and just a 3 here. Is there any outlier? Yes, as you see, this number is far away from the rest of the data, and it's called outlier. Another graph that we want to talk about is called a line graph. Line graph, we usually use line graph for continuous data. Continuous data means quantitative data when we have numbers only, okay? For the line graph, we always have two axes, horizontal and vertical axis. Horizontal axis, or sometimes we call it the x-axis, usually represent the data, and the vertical axis, or the y-axis, shows the frequency, okay? And for each of the data, based on the frequency of that data, we plot some points on the line graph, and then use line segment to connect the points. Line graph usually tells us the trend, if the trend going upward or going downward. For example, we want to track a patient's heart rate over time. So the best graph that we can have is a line graph because it shows us the trend. And that's an excellent graph to show the pattern between the data. And one of the most important graphs, line graphs, is called time series graph, which I will explain in the next section, section 2.2. Okay, let's create a line graph for this table. Okay, so for this table, which shows the result of a survey, 40 mothers were asked how many times per week a teenager must be reminded to do his or her chores. And the results are in table. Okay, as I said, we need two axes, the horizontal axis, which are usually data, and the data in this example is the number of times teenager is reminded, and we need a vertical axis, which is always the frequency. Okay, so we put the number, the data, we keep the same distance, disregard what numbers are, 0, 1, 2, 3, 4, and 5. I don't need to keep the zeros and the crossing point between the axes because this is a graph to show the shape of a distribution. That's not the calculus, okay? So 0 can be, you can just look at the 0 like any other numbers, okay? And the frequency, but the frequency must always be in order. So from 1 to 14, I must have all the numbers there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the first number, 0, the frequency is 2. Okay, I'll just put a point. The first one. The next one is 5. Point. The next one is 8. Next is 14. Next is 7. And the last one is 4. And then we use line segments to connect the point. That's it. That's a line graph. Next graph is called the bar graph. Bar graph, as you see in the picture, it's a graph of bars with equal width, which shows each bar shows the frequency of the categories. And we usually use bar graphs for comparing the different categories. Okay, for example, we have number of students enrolled in different majors. So we can use bar graph. And each bar should represent one of the frequency of the enrollment for a different major. Okay, and we can use rectangles or rectangular boxes if you have a three-dimensional. Bar graph, like line graph, also have two axes, the horizontal and vertical axis. Again, the x-axis or the horizontal axis shows the data, or in this case, the categories. And y, or the y-axis or the vertical axis, always is the frequency, the number of times the frequency of each category. And since we mostly use the bar graph for comparing the categories, it's the best graph for comparing the, when we have qualitative data. Qualitative data means we don't have numbers as a data. For example, we want to create a bar graph for the table, which is the result of a survey asking people about their favorite movie type. Okay, so we need two axes, the vertical and horizontal. We need the categories for the horizontal axis, the categories are comedy. Just put the categories. Sorry for my handwriting. It's hard writing on the screen. So action, romance, drama, and the last one, which is time. And again, the vertical axis is always the frequency. The frequency for comedy is 4. Don't forget, don't just pick some random places for the frequencies. The frequency must always start from the 0 and just go in order. 1, 2, 3, 4, 5, 6, 7. If you have large numbers for the frequency, you can go by 5, you can go by 10, but you still need to go in order, okay? Don't just pick random places. So the comedy is 4. So I need a bar over here. So to 4. For action, I have 5. A rectangular box. Romance is 6. The ruler, sorry. Drama is 1. And the last one is 4. And that is a bar graph. We can also create bar graphs when we have quantitative data, when we have data that are number or like classes. Okay, for example, as you see in this table shows the 3 age group and the number of users in each group and the proportion of these users, okay, that they use Facebook, I believe. Yeah, I didn't read the full sentence. So the age group are the data, and the proportion this time is the frequencies. Proportions are relative frequency, but that's fine. We can use the relative frequency instead of the frequencies for the vertical axis, okay? And so since we have 3 different age groups, we will have 3 different bars, and we show the proportions on the frequency part. So as you see, we have proportion on the vertical axis from 0 to the most number that we have here is 45, so we can just go up to 50. Or if you have more, you can go up to 100 because that's a percentage, and percentage is just from 0 to 100. And the age group, 13 to 25, 26 to 44, 45 to 64. And based on the proportion of each group, we have bars on top of each of the categories. Okay, next section, section 2.2 is talking about the 3 different graphs. And I will also added the pie chart at the end of this section because it's important that you may not find it in the textbook, but I prefer that we go over that as well. The first graph in this section is called the histogram. Histogram also consists of bars, but joining boxes, joining bars. As you see, it is similar to the bar graph, but the bars are touching each other. There is no gaps between the bars. Like bar graph, you have 2 axes, the vertical and horizontal axis. The vertical axis always shows the frequency, and the horizontal axis always shows the data. But the data that we use for the histogram are always the quantitative data. That means when we have numbers. And for the vertical axis, we can use frequency or relative frequency. Okay, histogram is one of the best graphs that shows us the shape of distribution, especially in chapter 5 or 6. We will use histogram to see the shape of the distribution, if the distribution is symmetric or uniform, and it's important for us to know in that section. And if you want to compare the bar graph with the histogram, you will see that in bar graph, we have gaps between the bar, but in histogram, we don't have any gaps. Bar graph usually we use the bar graph for categories, for qualitative data, but we use numbers or numerical data for the histogram. And the vertical axis in both of them are showing the frequency or the number of values for each category or the frequency for each data in histogram. But the question is how we can create bars which there is no gap in between. If I look at this table, and if I want to create a histogram for this one, so for sure I will have one bar for this class, which is 155 to 190. So from 155 to 190, I can create one bar for the first class. And as you see, the second class is starting from 191 to 226. And if I create a bar for that class, there is a gap in between the bars. I can use the classes because if I want to use the classes, for sure I will have gaps between the classes because the classes are not overlapping. So what can I do now? I can use the class boundaries. What is the class boundary? Class boundaries are the numbers that we use to fill the gaps between the bars. Okay, so how do we find the class boundaries? To find the class boundaries, we need to find the gap first. If you look at this example, the gap between 190 and 191 is just 1. So that means I subtract the lower class limit of the first class from the upper class limit of the second class. And if I subtract 190 from 191, I get 1. And this gap must be divided by 2, which gives me half or 0.5. And then I add this half of this gap, which is 0.5, to the first class and added the other half to the second class to fill the gap. So that's why I put these steps here. So we subtract the upper class limit for the first class from the lower class limit of the second class. Then we divide the result by 2, and after that we subtract the result from each lower class limit and add it to each upper class. So 0.5. 0.5 must be subtracted from each lower class limit because we want to go 0.5 back and then add it to each upper class. Okay. And if I do that, 155 minus 0.5 gives me 154.5. 190 plus 0.5 is 190.5. 191 minus 0.5, which is 190.5. 226 plus 0.5 is 226.5. 227 minus 0.5 is 226.5. 262 plus 0.5 is 262.5. 263 minus 0.5, 298 plus 0.5. 299 minus 0.5, 334 plus 0.5. And the last one. Now, if you look at the classes, you see there is no gaps between the first and the second class. I can create the histogram. So I will have 2 axes. Again, I put the class boundaries for each class. The first one is 154.5 up to 190.8. Second class is starting from 190.5, sorry, not 8, up to 226.5. 226.5 to 262.5. 262.5 to 298. 298.5 to 334.5. And last one up to 370. Again, the frequencies must always be in order from the highest number that I have is 7 So I only need from 1 to 7. 1, 2, 3, 4, 5, 6, 7. So we create bars. The first class goes all by 3. Second one goes up by 2. See, there is no gap between the bar. Next is going up by 5. Next is going up by 6. Then going up by 7. And the last one is going to 4. Now I have a histogram. And by looking at these bars, I can see the shape of the distribution later. Okay? Okay, next example. In this question, we have a histogram which represents the weight in pounds of members of a certain high school math team. Now it's asking how many team members are included in the histogram. If you look at this histogram, you will see different bars, which are the weight, the frequencies, which are the number of people in that weight. Which, for example, the first bar tells you there are 2 members with the weight of 115. This one tells me there is 1 member with a weight of 125, 3 member with weight of 135 pounds, 5 member 145 pounds, 1 member 155 pounds, there's no one with 165 pounds, and 3 members with 175 pounds. Now, when it is asking you how many team members, that means add the frequencies. If I add all the frequency of the bars, I have 2 plus 1 plus 3 plus 5 plus 1 plus 3, which is equal to 15. There are 15 members in this histogram. Next question. I have another histogram, which represents the weight in pounds of the member of certain high school debate team. Now it's asking you what's the class weight. The class weight is the difference between the 2 consecutive lower class limits or the 2 consecutive upper class limits. But when we have a histogram, we know that the upper class limit for the first class should be the same as the lower class limit of the second class. So that means the class width is the distance between the upper class limit and the lower class limit of each bar. And the distance between 100 to 110 is 10. So the class width is 10. What are the approximate lower and upper class limits of the first class? So the first class is from 100 to 110. The lower class limit and the upper class limit. We say the approximate because they are usually the class boundaries, not the exact classes, okay? Next graph is called the frequency polygon. The frequency polygon is similar to the line graph, but the only difference that we have in this case is that the first point and the last point usually connected to the horizontal axis, as you see here. But in the line graph doesn't touch the horizontal axis. And something else that's important about the frequency polygon always connect the class midpoints. Okay, so for the data in the horizontal axis, we put the midpoint. So that means we only use the frequency polygon for quantitative data when we have numbers, when we have classes, when we have big data set, we put numbers in classes and we use midpoints of each class as a data. Okay. And the frequency polygon is an alternative for the histogram. Since we're using lines, it gives us a smoother visualization and for each distribution. Okay. And like any other graph, the y-axis or the vertical axis shows the frequency. And it's also a very good graph for comparing when we have two or more distribution in one graph. Now, how we can create a frequency polygon? Let's look at this example. We have a data set with the classes of data, but we know the frequency polygon needs midpoints, okay? So we need to create another column in the table to find the midpoints first. To find the midpoints, if you remember, we add the lower class limit and the upper class limit of each classes and then divide it by 2. If I add 60 by 69 and then divide it by 2, it gives me 64.5 because that's a middle number in each class. And since the class width in this data set is 10, the midpoints also go by 10. So after finding the first one, you don't need to add or divide by 2 for all of them. You can just keep adding by 10. 64.5 plus 10 is 74.5. Plus 10, 84. Plus 10, 94. 104.1, 114.1, and 124.1. Now I have the midpoints. So it's easy to create the frequency column. So I put the midpoints for the data, which is 64.5, 74.5, 84.5, 94.5, 104.5, 114.5, and 124. So the frequencies must be in order from 0 to maximum 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We find the points for the first class. The frequency is 12, so we need the points on top of that. Just plot the points. Next one is 14. Next is 11. 1, 0, oh, again 1, sorry. 0 and 1. Now we connect the points. So far we have a line graph, but to make it as a frequency polygon, we need to connect the first point to somewhere before the first class and the last point to somewhere after the last class. And we need to find these two values as well. And you know all these numbers are the midpoints. So that means those two numbers also are midpoints. Okay, so we know that the midpoints are going by 10. After finding the first one, you just kept adding by 10. So if I add 124.5 by 10, it gives me 134.5, which is this point. And if I subtract the first by 10, it gives me 54.5. That's the first one. And since these two classes do not exist in this table, that means the frequency of these classes are 0. That means they have a point on the horizontal axis. That's why we can connect the points to these 2 points. And now I have a frequency polygon. Next graph is time series graph. Time series graph, as I said, that's a type of line graph, but the only difference that this one has is the time series graph shows the changes over time. So that means the horizontal axis always shows the time and the vertical axis shows the data because we want to see the data over time. Okay? So for example, if I want to create a time series graph for this example, these numbers are showing the women's median earnings as percentage of men's median earning for recent year beginning 1997. So that means the first number is for 1997, the second one is 1998, 1999, 2000, 2001, 2002, 2003, 4, 5, 6, and 7. So these number of years are your X or data, or X actually, or you put them on the horizontal axis and you put these data values for each year on the y-axis or the vertical axis. And after finding the points and using the line segment to connect the points, we get this graph. Okay? And it shows the trend, it shows the changes over time. And as you see, after 2001, the women's median earning went up. Okay? And the last graph is called a pie chart. Pie chart is one of the common graphs, which usually shows we use them for the categorical data or the qualitative data when we don't have numbers, okay? And we always show the data as a proportion or percentage, okay? And that's the best way to show the different categories, to compare the different categories contribute to a total of all categories. So for pie chart, we usually show each category as a slice of a circle. And since the total angle inside the circle is 360, we need to find the central angles for each of the categories by finding the relative frequency and multiply by 360. So we find the relative frequency, we multiply each of them by 360, and then we will have each of these angles. Okay? Let's look at an example. We have the number of earned degrees in thousands in 2019. We want to use the pie chart to organize the data. Okay, you see the type of degrees, the numbers in thousands. We want to show in pie chart, so that means we need relative frequency. Okay, we need to find the relative frequency. These are the frequency. To find the relative frequency, I need to know the sum of all frequencies. If I add all these frequencies, they add up to 4072. And if you want to find the relative frequency, you know that you need to divide each frequency by the sum of frequencies. And after dividing each frequency by the sum of frequencies, we get a decimal or percentage. Now to find angles, we need to multiply by 360 degrees, which gives me, if I just round it, it gives me about 92 degrees. For the next category, I have 2013 as a frequency divided by the sum of frequencies. And the decimal number I get is 0.49. If I multiply it by 360 degrees, it gives me about 178 degrees. And for the next one, which is 834, divide by 4072, it gives me 0.20. And if I multiply it by 360, it gives me 73 degrees. And for the last one, I get about 17 degrees. Now we need to create a circle. One optional radius. You can just choose it anywhere in the circle. And then we use the protractor. We put the protractor here. And then find angles. The first angle is 92 degrees. Oh, sorry. So 92 degrees. Then we put the protractor in this new line. We choose the next angle, which is 178 degrees. Then we put the protractors on this new line, like this. We choose the next angle, which is 73 degrees, and the remaining must be 17 degrees. Now I have a pie chart for this table.